Hello everyone. Today we are going to discuss about smart grids. Smart grids are the advanced electrical network which uses digital technology and automation technology to manage and communicate and supply the demand to the customers. So basically power flow is managed and communicated through the digital technologies. So it's because of the advanced communications technology, it is possible that smart grids can communicate with each load centers. So usually in previous decade, we do not have two-way communications. So the power flow always come from grid to the house, and there is a one way. Even the power flow is one way. Now because of the solar panels we have a two-way power flow. On top of that, we have not only the power flow, we have the communications as well. Communications mean in a real smart grid network, a grid operator can able to switch on and off individual loads. So each houses are can be considered as a connected to the switches. So from the computer sitting in the control room, from the computer they can able to cut the power to particular house or particular regions, particular distribution zone. So everything is possible without the manual intervention. So it means that it's an automated system. Not only a man can or the grid operator can switch off and on the devices, it also can we can run automation software. So the software itself take a decision, and it supply the power, and if necessary it cut off the powers, or I mean the load shedding. Everything is possible through the smart grids. So if you look at the picture, smart grids, always we have a communication. It means the smart grids simply means we are adding the communication on top the power flow. So we have a electricity flow from the grid to the houses. Now on top of the electricity flow, there is a communication channel is also added in this network. So this communication channel will help us to manage the entire network and operations. So we have all the factories, homes, um, power plant, hydraulic power plant, photovoltaic, renewables, all are connected in the smart grid. If you look at another diagram here, we have the wind farms, all the loads and the power production. If you look at the arrows, this is a beauty. We have a two-way communication. This is a two-way communication. Every arrow is a two-way. So early days, like there is a conventional power system, we have one-way communication. One way, power flow itself is one way. Now power flow itself two way, and the communication also two way. Sometimes the house owners says that I don't want the grid supply, so I'm going to cut off from the grid supply, so they can communicate. That's why if you study the last few videos, we studied about microgrids. Microgrids where we some number of houses together, we create our own grid, local grid. So in that case, we have to communicate with the grid always. There is a communication is necessary. Communication mean is a data, through the data. Like if there is a over voltage or under voltage. Early days, what we do is we have a relay system. If anything goes wrong, the relay will trip. We still have the relay, but how relays are triggered? Early days is a manual monitoring, or sometimes the analog meters we use analog meters, and we manually trigger the relays. But here is automation system. It means smart grids give an opportunity to have a automation system where the relays and breakers can be on and off through the computer programs. Automation mean everyone can understand that it itself, the program itself will take a decision and change the power flow. So that is the idea here. Let's say if we want to connect solar panels to the grid, that time the decision made by the the automation system, the smart grid automation system. The controller will take a decision. In other time, they want to cut off the solar panels from the grid, because in case there is over voltage happening in the grid, so we don't want to add more solar panels to the grid. In that case, again, the smart grid automation system will take a decision to cut off the solar panels output coming to the grid. So these all switching is done by the smart grids. So let's go into some definitions of smart grid. A smart grid is an advanced energy network that uses digital technology and automation to monitor, communicate, and manage energy flow efficiently. As I said, as a power system engineers, we are making sure the power flow, energy flow, should be efficient and less cost effective. So to do that, we need with the modern power system, we have solar panels, renewable energy resources, local power generation. We call distributed power generations are available. It is much complex. So we need a smart system which can monitor, communicate digitally. That is a smart grid. It improves the reliability, efficiency, and sustainability of power delivery by incorporating real-time data. This is a key, real-time data. We need the real-time data. So every 5 minutes, in some places every minute, we collect the data. I mean, real-time, that's a communication. Communication means the real-time data, what voltage, how much active power flowing, how much reactive power flowing, what is a ampere rate, what is a frequency, what is a power factor, all sort of information, all the parameters, electrical parameters are communicated in real time. That is a meaning of communications. Decentralized power sources. Okay, we also dealing with decentralized, as I said, where solar panels are decentralized power sources, power generation, and responsive communication between consumer and utility providers. So it is basically giving a communication channel between the consumer and utility providers in a better way, in a smart way, through the digital communication and the real-time communication. Okay, the smart grids are pivotal in supporting renewable energy integration, distributed energy resources, and enabling more resilient energy infrastructure, because there is a need. It's not just a communication is a new technology, there's a necessity, because when we have more renewable solar panels in our rooftop, these solar panels are power plant, actually it's a power plant, so we are generating electricity. So we become a kind of power plant owners. So we are now playing a part in managing the grid. Like in a conventional power plant, if let's say we have a hydro power plant, a thermal power plant, we have numbers of 5 numbers or 6 numbers of these major power plants. They are the big players in the electricity market, or the electricity operation, in terms of grid operation. But when we come to nowadays, the modern distributed power generation, I mean, with the solar panels, what happens, like whoever having the solar panels, they become a player, the main, the not the main player, is the part of the player in the grid operation. So you are also part of the grid operation. So you become a grid operator. So now solar panels producers have to give a proper communication to the main grid operators. That's then only we can manage a system. So with real-time data, we have to collect and monitor the data, and we have to predict how much energy you can export to grid tomorrow. So those things are need a smart system where digital communication and automation is needed. So that's why we study about smart grids. So what are the key features of smart grids? That's a two-way communication, not just one way. It's just two-way communications. An advanced metering infrastructure that we call AMI. So we have everywhere, we have a voltmeter, ammeter. These are digital meters, and these are connected to an IoT based device. IoT means Internet of Things. IoT based devices mean is the data is sent to cloud and quickly sent to, and in real time. There's no time gap. Okay, in real time, the data is read by the grid providers. So that those are the advanced metering infrastructure. And distributed energy resources, DER, solar panels, these are the distributed energy resources. Distributed energy resources mean the power generation is distributed everywhere. That's a meaning. So automated controls and self-healing. So it's automated control. Some if there is a fault happen early days, 10 years before, if there's a fault happen, then the lineman or the technician come to the road, and we call the technician, and someone come to the road and check and isolate the breaker to remove that fault location, separate the fault location. Nowadays, with the smart automation system, if there is a fault happen, the smart grid itself sends the fault. And if we find the fault without any human intervention, it cut off the supply to that particular region or particular poles and wires. So this is all possible through the smart grids. Okay, so the maintenance and repair is the troubleshooting. These are become very easy and can be done within less time period. Okay, then dynamic pricing and demand response. So dynamic pricing mean we can fix the price of electricity based on demand. So within a day we can fix 5 different prices for the electricity. So dynamic prices are possible only because of these smart grid technology. The last one is data analytics and artificial intelligence. So in this smart grid technology, the data analysis and artificial intelligence are playing the huge role, because it's a lot of data coming, because from the grid, because it's the smart grid, a lot of data is coming to the smart grid operator. So he has to handle all the data, because there are a lot of faults and wires everywhere. We have a voltmeter, ammeter, watt meters, all the power quality measurements, all the measurements coming, and then load demand data is coming. So all these things will have to be handled, managed very well. That's why we need the data analytics and the artificial intelligence we need. So we look at the two-way communication. Smart grids enables two-way communication between power providers and consumers, allowing real-time monitoring, data collection, and adjustment to improve efficiency. So as we explained, we have a two-way communication. This improve the data collection, efficiency, and monitoring. This interaction allow for dynamic responses to changes in demand, reducing power outages and enabling protective maintenance. Sorry, proactive maintenance. So what are the things here? We dynamic response to change in demand, because when change in demand comes, we have to react immediately. We have to increase the power generation, or we have to do some other strategy. So in that case, with the smart grids, so we can dynamically respond. Dynamically mean within a second or within a few seconds, we can react to change in demand. That will help us to maintain the frequency, because if we delay in responding to changing demand, then we will face the frequency problems. Okay, so with smart grid technology, the information are very quickly reach to the operators or the control center. So then the control center can easily react to the changes, because power system always keep on changing. Is a highly dynamic, because the users are having a different demand pattern. They use the different consumption pattern, and the different demand in a different timeline. So it's super dynamic. So we have to react faster, so that the smart grids help us to react faster. Then advanced metering infrastructure, this is we call AMI. I highlight these keywords because this is as a power system engineers or electrical engineers, we need to know these short forms, AMI, the abbreviations. So this is important, because then only we can understand, and the technical words, keywords. Okay, AMI includes smart meters that provide real-time energy consumption data to both the utility and the consumers. So it provides the real-time data, as I said, the voltage, ampere rate, wattage, every data it is can collected and transferred to the AMI infrastructure. Smart meters facilitate dynamic pricing, dynamic response, and better energy management for consumers, as they can see then when energy is cheaper and adjust their usage accordingly. This is a key, very important area here, because through these smart metering, we can have a dynamic pricing, and consumers adjust their usage pattern based on the time where the cheapest price available. So usually in developed countries like Australia, America, these kind of developed countries, they have a dynamic pricing mechanism. So every day they will inform that whether the electricity is cheaper now, or so you can easily from the application apps you can see the price today, what is the price of electricity. So if the today price is cheaper, then you try to use more on today. So tomorrow if the price is high, then you try to reduce the usage likewise. And also we can implement demand response program. Demand response program means a grid operator requesting you to reduce your usage on a particular day suddenly, because of some issues in the power plant or any major issues in the power generation sector. The grid operator cannot generate enough power to meet the demand. In that case, what grid operator will do? Grid operator will communicate to the consumer asking, can you reduce your usage today? If you reduce your usage, we will pay some money as incentives. So this is called demand response program, DR. So these all program is possible only through the uh, smart grids, because then only we can communicate in time basis. Okay, and we can take a smart decisions. Okay, distributed energy resources. So the smart grids accommodate decentralized power sources like solar panels, wind turbine, battery storage, and even electric vehicles, which can contribute energy back to the grid. So we already studied this. Okay, distributed energy. So we have solar panels, wind farm. This all we are locally generating and sell or export to the grid. With DER, the grid can balance power supply more effectively, reducing reliance on large centralized power plants and supporting cleaner energy. So with DER, they can easily balance, because for the DER, there's no need to send transmit power for a long distance. Because DER is locally available within the distribution area. So it is cheaper to generate locally and use it locally. So that's a concept of DER, distributed energy resources. Okay, automated control and self-healing. So automation technologies detect and isolate fault, rerouting power around problems area to reduce the impact of the outage. As I explained earlier, a person, a technician, no need to go to the site. The system itself will isolate the fault. Okay, isolate the fault location. These self-healing capacities help maintain grid stability, reducing outage time, and improving resilience in the face of storms, natural disasters, and cyber attack. So, because these during the natural disasters or these kind of times, the poles and wires are breaking or falling down. These during this time, if we have a smart grids will isolate the area. So that is better. Okay, dynamic pricing and demand response. By adjusting the electricity prices based on demand, utilities incentivize consumer to reduce consumption during peak hour times. I already explained. Okay, utility, the grid provider asking, can you reduce your demand today? Can you reduce your consumption today? I will pay some money. This is a dealing. This is a win-win situation. If you say yes, then they will pay you some money in order to sacrifice your usage, the consumption. Okay, and helping them. Okay, this will help balance the load and reduce strain on the grid. So There's a one great program in developed countries. It is available in developing countries. In future, it is possible because in developing countries we don't have a smart grid. So that's why without smart grid we cannot have this demand response program. Okay, that's a key. Demand response program allow utilities to adjust power supply during peak demand, either by communicating with smart devices in homes and business, or by offering incentives to consumers for voluntary reduction. So there's a voluntary reduction. If you like, you can say yes, or we can reject it. So we come to the last slide. So data analytics and artificial intelligence, AI and data analytics help predict demand, optimize generation and distribution, and identify potential issues before they occur. Okay, these tools enable utilities to make data-driven decisions to improve grid efficiency and proactively maintain infrastructure. So these keywords are important. The data-driven decision. Data-driven decision is a famous keywords in the IT sector or any other the robotic and artificial intelligence sectors. So data-driven decision mean we have a algorithm running in the power grid, the controller. I mean the our controller, the control room having the computer with a lot of algorithms are running. So through the smart meters, we collect data. So that data is fed into these computers, the software programs, and we that software itself take a decision. Will take decision that is called data-driven decision. It decisions are based on data. The decisions are based on voltage, current. These are the data, and active power demand, active power generation. So these are the data based on timely data collected by the control center. These decision can be made. So this is a very beautiful things because the person no need to the control human no need to interfere in this controlling, because early days control center have a lot of employees sitting there in the computers, and even some in developing countries we have over the phone we get complaint on the data. Based on that we are doing. Okay, I think we come to the end. Thank you very much. It's quite a long video. Thank you very much for please continue watch my videos. See you in the next video.